It's Daddy Cause again, and in this video we'll be looking at rusting as an electrochemical process. Rusting is a form of corrosion in iron. Actually, metals corrode when they have access simultaneously to oxygen and moisture. So metals will undergo corrosion. Corrosion is a degradation brought on metallic objects when they have access to oxygen and moisture. In fact, corrosion becomes faster if there's electrolyte in the air. For example, there's pollution that brings about sulfur 4 oxide or carbon 4 oxide. These gases are able to dissolve in water to form electrolytes. So because of this, any metal structure around tends to corrode faster than they're supposed to corrode. So, but in this video, I'll be specifying, or I'll be, boiling this thing down to rusting of iron. Rusting is a form of corrosion in iron. Different metals have their own corrosion products, like copper is patina, silver is silver tarnish. But in iron, the corrosion product of iron is called rust. So we call it generally rusting of iron. So like every other metal, iron will rust when it's combined with oxygen in the presence of water, and the product will be an hydrated iron 3 oxide. Iron 3 oxide is what is known as rust. Hydrated iron 3 oxide is what is known as rust. Now, in the case of iron, the rust that is formed is very soft and flaky. It can break off easily. That's the meaning of flaky. It can break off easily, and whenever the rust form and it breaks off, it will expose the internal layer of iron to more corrosion, and then it rusts again and flakes off and expose the internal layer of iron to more corrosion. So if an iron begin to rust, the iron is sure to rust completely, because the rust layer don't stick to the surface of the metal. The rust layer will flake off and expose the fresh metal inside to another layer of rusting until all the iron completely gets rusted. So the equation for the rusting of iron is given below, and it is very advisable that you know this equation, where iron, and it's very easy to know, just say that iron reacts with oxygen in the presence of water. That is condition for rusting of iron, to give us hydrated iron 3 oxide. Hydrated iron 3 oxide. That hydrated iron 3 oxide is known as rust. So master the equation: iron 4 of iron, 3 of oxygen, 2 of water, 2x of water, to give us 2 moles of rust. That is rusting of iron. Now, there are 2 major stages involved in the rusting of iron, and this is a very examinable question. Discuss the stages involved in the rusting of iron. So if you are to be asked this question in any exam, what should be the proper response? So the first thing that happens is that the iron metal is first oxidized by oxygen and water to give iron 2 hydroxide. So actually what actually happens is that the iron become oxidized to iron 2 oxide, whereas the water become reduced to the oxygen become reduced to OH minus. So both of them will diffuse together and form iron 2 hydroxide. But simply say iron is oxidized to iron 2 by oxygen and water to give iron 2 hydroxide. Then further oxidation of the iron 2 hydroxide will now give us hydrated iron 3 oxide. So that is those are the stages involved in the rusting of iron. The iron goes into solution first as iron 2 by oxygen and water. They are the agent of that oxidation to give iron 2 hydroxide. Then that iron 2 hydroxide will now further oxidize to iron 3 oxide hydrated, which is what we call rust. Now, how can you prevent this reaction from occurring? How can you prevent rusting of iron? I have made a video on corrosion of metals where I analyze 7 different ways of preventing rusting of iron. Talk about electroplating, talk about galvanizing of iron, talk about painting of metals, talk about greasing and oiling the moving part of engine, talk about enameling, you enamel plates, talk about enamel, talk about alloying, then talk about sacrificial cathodic protection. So in this video I will only be looking at the sacrificial cathodic protection, because apart from electroplating, which we have done under electrolysis, another electrochemical or redox process of preventing iron from corroding is sacrificial cathodic protection. Now we know that electroplating is an electrolytic process. Now, sacrificial cathodic protection is an electrochemical process of protecting iron from rusting. Now, have you ever wondered why blocks of zinc are attached to the ship's hull? These whitish uh, these whitish materials are zinc blocks, zinc blocks, zinc blocks, zinc blocks, zinc blocks. All those whitish stuff are zinc metal attached to ship's hull. This is ship's hull. Can you see the bottle? That is ship's hull. Now this ship's hull is having a direct contact with water, and we know that oxygen is also dissolved in water. That's a sufficient condition for corrosion to take place, and extra care must be taken, because if the ship's hull begin to corrode, that means water will have access into the ship, and you know what happen when water enters into the ship is going to sink, and when ship sink, people dies, and that is not the a good advantage for using ship as means of transportation. So to avoid this, we have to put into place method to prevent the ship from corroding, the ships or from rusting, and that is why you see blocks of zinc attached to that ship hull. I'm going to give you the chemistry of what we are looking at right now. Another way where we have applied sacrificial cathodic protection is in underground pipe. When you run iron pipe through the through the underground layer, there are many mineral salts inside the soil that can act as electrolyte and accelerate rusting of iron. So if you don't want the iron to rust quickly, you also have to do a lot of things. Imagine the iron pipe used to transport petroleum. It can run from a very long distance. How do you protect this iron pipe from rusting? Because if any part of the iron pipe is become rusted and start leaking, what will happen is that petroleum will start leaking out, and there will be wastage of resources. So to prevent this, you see at every interval blocks of magnesium is attached to the to the underground pipe. This to prevent the iron from corroding. But what is the chemistry behind this attachment of zinc to ships or attachment of magnesium to iron pipe? That is what is known as sacrificial cathodic protection. So what is sacrificial cathodic protection? Is a method of protecting a metal by attaching blocks of more reactive metal to it. When you have a metal A, and you attach another metal B to that metal A, Then an electrochemical process will be set up. One of the metal A or B will become the anode, the other metal will become the cathode. And usually from your knowledge of electrochemical cell, you know that it is the more reactive metal that will serve as the anode, where the less reactive metal will serve as the cathode. And again, from your knowledge of electrochemical cell, you know that it is the anode that normally dissolve and produce electron, right? In this case, the word dissolve will be standing for the word corrode. So it is the anode that we, corrode, in this case of protection now, or dissolve, whereas the cathode is one that will merely accept the electron and become reduced. So when you attach, well, when you attach two blocks of metal together that are different, the less reactive metal will be the cathode, the more reactive metal will be the anode. Now, because the anode is more reactive, so the anode is more likely to corrode than the cathode. So when you attach two metals together, the more reactive metal is the one that will corrode, protecting the less reactive one. Take note of that. And that's sacrificial protection. So that more reactive metal that you attach to a less reactive metal will be corroding, and then the less reactive metal will remain intact without corroding. So that more reactive metal, the anode, which is undergoing corrosion, is as if you are sacrificing it. You are allowing it to corrode. So that metal is called sacrificial metal. It's like, you just finished from a school now, and then you are going back to school to go and collect your certificate. Now when you get there and they give you the certificate and everything, then you start coming out from the principal's office or whosoever is giving you the certificate. Then rain start falling. You have a textbook in your hand, or probably of the school that you have finished from, and then you also have the certificate in your hand. Those are the two things you have in your hand. What are you going to do? Will you use the certificate to protect or to cover the textbook, or you use the textbook to cover the certificate? Now your guess is as good as mine. You are going to put the certificate inside the textbook, right? So that as the rain is falling, the rain will be falling on the textbook and not on the certificate. So in this case, what are you doing? You are sacrificing the textbook to protect the certificate. This is called sacrificial protection. You are sacrificing one thing to protect the other one. So that's also what happens in sacrificial cathodic protection. You are protecting the cathode by sacrificing the anode. So when it says cathodic protection, you are protecting cathode, which is the less reactive metal, by sacrificing the anode. So that kind of arrangement, the more reactive metal becomes anode and corrode first, and until that more reactive metal completely corrode, the less reactive metal will not corrode as long as it is joined to that more reactive metal. So in that case, you are sacrificing the anode, which is the more reactive metal, and using it to protect the cathode, which is the less reactive metal. So let's look at this short exercise. A tin coated plate and a galvanized plate. Tin coated means, let's assume the plate is iron, for example. So iron is coated with tin metal. That's a tin plated iron. Then a galvanized iron plate, that is, the iron is coated with zinc. The word galvanized means protected with zinc. Tin coated means protected with tin. Now, which of the two of them will corrode faster if they are both, you know, uh, exposed to the same level of handling? That is the question that I want to answer in this video. Now let's look at the video. Let's look at the question together. We have two situation at hand. Iron cover with tin, that's tin plated. So this is tin. The outside one is tin, the inside one is iron. Then also we have another situation, iron cover with zinc. This is iron inside covered with zinc outside. Now, this particular arrangement is okay. Both the tin and the zinc are covering iron. If the if the covering is complete, all the iron are covered, then the iron will be protected. Now this kind of protection is not electrochemical protection. It's just as if you took an iron and you painted the iron. Now that paint will prevent iron from corroding because the paint will block oxygen and water from having access to the iron. Fine. So that's similar case in this place. Zinc completely covered the iron, tin completely covered the iron. But immediately there's a scratch. Immediately there's a scratch and you see something like this. The layer of the tin is scratched, and the layer of the zinc also is scratched. What happens? Then what we are going to be having will be as if you are now attaching the zinc to the iron, right? And attaching the tin to the iron also. That's what you are going to be having. So you are attaching tin to iron and attaching the zinc to iron. Once there's a scratch, so in this case now, electrochemical cell will be set up because the zinc is no longer protecting the iron by covering it because there's a scratch, and the tin also is no longer protecting the iron by covering it, so there's a scratch. So the kind of protection that can happen here now is electrochemical protection, which is sacrificial cathodic protection. So if iron and tin are connected together, if iron is connected to tin, this is iron, this is iron, and this is tin, and there's a scratch, right? Good. Which one will serve as the anode? Which one will serve as the cathode? Now, because tin is lower than iron in the electrochemical series, tin will serve as the cathode. The lower metal will be the cathode. Iron will serve as the anode. So we know what normally happens. The anode is the one that corrode first and protect the cathode. So in this kind of arrangement, the thing that we are not intending to protect is the one that will get protected because it's lower than iron. So in this case now, iron will be corroding very fast, in fact faster than it's supposed to be because of the presence of tin. So the iron is not well protected in a tin plated arrangement because once there is a scratch, the tin becomes anode, the tin becomes the cathode being lower than iron, the iron becomes the anode being higher than tin in the electrochemical cell. So what happen is that the iron, because it is more reactive, will start corroding, leaving tin behind. But in a galvanized iron, where the iron is covered by zinc, so this is zinc layer, if there is a scratch, then what we are going to be having will be electro sacrificial protection, which means one of the metal must corrode and protect the other metal. So in this case where we have iron and zinc, between iron and zinc, which one is higher or which one is more reactive? The answer is zinc. So zinc being more reactive will be the anode, unlike the former arrangement where tin is covering iron, and because iron is more reactive, iron is the anode. But here zinc is more reactive, zinc will be the anode, then iron will be the cathode. So even after there's a scratch, and there's now sacrificial protection. It is still the zinc that will be protecting the iron. Why? Because the zinc is more reactive than iron, so the zinc will be corroding, leaving iron behind. So as long as the iron is still attached to the zinc, the iron will not be corroded. The iron will not corrode, because the zinc, being the more reactive one here, will serve as the anode and continue to corrode. So until all the zinc completely corrode before iron can start corroding. So this is a sacrificial protection that we talk about. So if you are asked this question in exam, what should be your correct your proper response? Your proper response will be that because zinc is more reactive than iron, zinc will enter into solution and corrode, preventing iron from corroding. But because tin is less reactive than iron, iron will serve as the anode and corrode, whereas tin will not be affected. Hence, iron will be better protected in a galvanized arrangement than in a tin plated arrangement. That will be your proper response. So this will be the end of our uh, of our lectures on electrochemical cell. God bless you. Amen.